Good morning, students. We have met once again for discussion of a part of nervous system which constitutes a trilogy comprising of the reticular activating system, EEG. These two things I discussed in my last class, and today I shall talk about sleep. So these three things, that is reticular activating system, EEG and sleep, are structurally and functionally interconnected. Now, so far as the sleep is concerned, most of you have got the experience of sleep. I'm not going into the details. But one important thing which must be emphasized, that the utility of sleep should be emphasized. Why? Because it has been seen that whenever there is long deprivation from the sleep of any subject, prolonged deprivation of sleep from any subject, there are impairments of higher intellectual functions. Number one, like the memory, like learning, like judgment, and also there is impairment of the motor functions of the subject, particularly the control of the different muscles of our body, so that the coordinated action of the body is possible. It has been seen by experiments that due to long deprivation from sleep, these are the consequences on the subject's biological system. And that's why the utility of the sleep can be ascertained from these facts. Now, that is the utility. Now, we will go to the definition of sleep. It's a very difficult to define, I think. Very difficult to define. Why? Because sleep is said to be a reversible physiological condition where the subject is completely dissociated from the environment and is unresponsive to stimuli of different natures. So, sleep can be defined in this order. It is a reversible state, or in this manner, it is a reversible physiological state where the subject is unresponsive to conventional sensory stimuli along with perceptually dissociated from the environment. So that should be the correct definition, I think. So after that, we shall go into the details of sleep. Now, if we consider the sleep as a normal physiological phenomenon, it has been seen that a person spends 1/3 of his lifespan in sleep. 1/3. So no matter, it's a considerable amount of time which is spent in sleep. There is a 1/3 of the lifespan of the subject is spent in sleep. So that is very, very important so far as the duration of the sleep throughout the life is concerned. Now we will go into the different aspects of the sleep. Different aspects of the sleep. Now, the features of sleep. What are the features? If you consider the features, we may divide the features into two parts. One is the clinical feature, another is the electroencephalographic feature. I will go into the electroencephalographic or EEG features later on when I will describe in details. Let us consider what are the clinical features of sleep. Now, during sleep, what happens to different parameters of our body? Different parameters like the heart rate, pulse rate, then the coelomic temperature or the core temperature of the body, they all decrease. There is reduction of the skeletal muscle tone of the body, and there is decrement in the rate of respiration but increment in the amplitude of respiration. That is, the depth of respiration goes high, whereas the rate of respiration becomes low. So these are the different physiological parameters which are associated with sleep. Now, one important aspect in this case must be emphasized or must be mentioned, that the secretion of growth hormone is the only exceptional physiological incidence which occurs is increased. The growth hormone secretion is increased during sleep. This is the only parameter which is increased during sleep, and that is the reason that the children are having a huge amount of time in sleep and they grow properly because of the proper secretion or adequate secretion of growth hormone. So these are the features, clinical features of sleep. Now, in this respect, another important thing must be emphasized. What is sleep wakefulness cycle? Very, very important. Sleep wakefulness cycle. Say, for example, a person sleeps 8 hours in a day. So, quite naturally, he remains wakeful in 16 hours. 8 hours in sleep. So, 16 hours remain wakeful or awake. So, his sleep wakefulness cycle will be 8 upon 16. This ratio must be kept constant for an individual subject. For any individual, this ratio, known as the sleep wakefulness ratio, must be kept constant. If there is any derangement of this ratio, say for example, if the person sleeps less, then consequently after 2 to 3 days, he balances the lost amount of sleep or the deficient amount of sleep so that the ratio becomes normal once again. This sleep wakefulness cycle is a classical example of circadian rhythm of sleep. This is known as the circadian rhythm of sleep because it occurs in a 24-hour cycle in a day, or it is also known as the homeostasis of sleep, sleep homeostasis. So that is about the sleep wakefulness cycle. Now we shall go to the sleep cycles. What are sleep cycles? Now, say for example, in a night of 8 hours sleep, there are many cycles of sleeps. If you consider each cycle, then it happens that at the beginning there is a cycle and at the terminal part there is another cycle. The cycle which is at the beginning is known as the non-rapid eye movement cycle or NREM cycle. Non-rapid eye movement cycle or NREM cycle. And the last part of the cycle, each cycle, where the eyeballs move very rapidly, is known as the rapid eye movement cycle or the REM cycle, REM cycle. Now let us discuss these two important cycles of sleep. These are the main characteristic features of sleep. So far as the non-rapid eye movement sleep is concerned, it is composed of 4 stages: stage 1, stage 2, stage 3 and stage 4, where the subject remains in a different stages of sleep right from the twilight between the wakefulness and the dozing, then from the dozing to the first part of the NREM sleep, then the second, then the third, then the fourth, off and on, followed by the REM sleep. So these cycles are very important to be discussed. NREM sleep, non-rapid eye movement sleep. Why the nomenclature is there? This nomenclature is due to the fact that right at this stage of sleep, there is no movement of the eyeball of the sleeping subject. Now, here the muscles are relaxed slightly and other parameters which I mentioned during the clinical features, they start declining gradually. It is composed of 4 stages, as I told you: stage 1, stage 2, stage 3 and the stage 4 with characteristics EEG changes. I am going to these changes later on. Now that is about the non-rapid eye movement sleep. That constitutes the initial big portion of the sleep cycle. Now it has been seen that each sleep cycle is of duration of 90 minutes, that is 1.5 hours, of which the initial 70 minutes is for NREM sleep and the last 20 minutes for the REM sleep or REM sleep. So initial 70 minutes NREM sleep and the last 20 minutes for the REM sleep. So that constitutes one cycle. If a subject, say for example, sleeps for 8 hours in a night, so there will be, if cycle is of 90 minutes duration, so there will be at least 5 cycles in a night, and the sleep goes on in this manner. So NREM, REM, NREM, REM, NREM, REM, like this. In each cycle is composed of 2 stages, NREM and the REM. NREM is of the duration of the 70 minutes roughly, and the REM is of duration of the 20 minutes, so total 90 minutes. That constitutes a single sleep cycle. There may be such 5 sleep cycles or 6 sleep cycles or 7 sleep cycles depending upon the total duration of the sleep of the subject. Am I clear? So this is the features of the REM sleep. Now in NREM and the REM sleep. Now in REM sleep there are some characteristic features. In REM sleep, the subject's eyeball, if you observe in a subject who is sleeping, then there is a rapid movement of the eyeball which is visible from the external side, though the eyelids are closed because the subject is sleeping. So there is rapid movement of the eyeball, and that's why the nomenclature is rapid eye movement or REM sleep. This phase is characterized by profound reduction of muscle tone known as hypotonia, and in this phase, very very important, the person dreams. So in the REM sleep period, the person dreams. Though the eye movements are observable right from the external side, that there is rapid eye movements are there, still right at this stage the person is at a very deep stage of sleep, and as a result of these two opposing facts, the REM sleep is also known as paradoxical sleep. Paradoxical sleep. Paradoxical means which apparently you are seeing as the normal thing, but that is not actually the normal thing. That is a paradox, you know quite well. So paradoxical sleep, movement of the eyeball are very very rapid, but still the person's muscle tone is very very low, and the person cannot move any part of his person, and even the stage of the sleep is very very deep. So that's why it is known as the paradoxical sleep. Now we will go to the EEG features of the NREM sleep and the REM sleep. Now let us consider the NREM sleep first. As I told you earlier, that NREM sleep is composed of 4 stages. Stage 1, stage 2, stage 3 and the stage 4. Now in case of the stage 1, the characteristics waves, as I told you, perhaps you can remember my last class what I talked about the different waves of the EEG. It is composed mainly of, what it shows rather, stage 1, mainly the theta waves which are low voltage or medium voltage high frequency waves. Medium voltage high frequency waves. These are the theta waves, which is a characteristic phase of stage 1 NREM sleep. Stage 1 NREM sleep characteristic features theta waves. Right. These theta waves, they undergo a considerable change in stage 2. The person is gradually going into the deeper stage of sleep. So also there will be reflection in the electroencephalogram. So stage 2, we find a characteristic feature of the EEG wave known as sleep spindles. This portion is known as the sleep spindles, where there is high voltage or high amplitude waves are seen, and which are juxtaposed to each other in such a manner that they are fused waves, giving this impression or bold impression over here. The sleep spindle is a very, very important characteristic feature of stage 2 of NREM sleep. Now, if you go on tracing the stage 2 EEG, then after the sleep spindle, there will be a very high spike followed by a very high frequency, roughly 14 Hertz frequency wave. So this portion of the stage 2 EEG, that is the sleep spindle followed by a single high spike of the amplitude followed by a very high frequency wave, is known as the K complex. Known as the K complex. So this is the sleep spindle of stage 2 and this is the K complex of the stage 2 NREM sleep electroencephalographic picture. Am I clear? So that is about the EEG picture of stage 2. Now from stage 3 onwards, the EEG waves become very, very slow but is of very high amplitude, showing the classical delta wave. As I told you in the last class, that the delta wave is a very high amplitude, more than 100 microvolt in amplitude, and the frequency is very less, 1 to 4 Hertz or 1 to 3 Hertz nearly. So from stage 3, this particular wave is known as the slow wave sleep, SWS, or slow wave sleep, and that is characteristics of the delta wave. So also in case of stage 4, the features are similar to that of stage 3. The waves become more high, waves become more high amplitude, as well as the very low frequency. So stage 3 and the stage 4 of NREM sleep are classically known as the slow wave sleep or SWS. Right? Then after the completion of the stage 4, it is automatically switched on to the REM sleep. So initial 70 minutes are gone, followed by rest 20 minutes. So from stage 4, there is automatically switching over of the sleep phase from NREM to REM. Is this clear to you? So these are the EEG features of stages of NREM sleep. EEG features of stages of NREM sleep. This is very, very important. Now the question comes, after the stage 4, there is REM sleep. During REM sleep, what will be the EEG picture of the subject? Any guess? During REM sleep, the EEG picture will show the classical of alpha block. In the last class I talked about you, that is the commonest wave found in the occipito-parietal region is the alpha wave, whose amplitude is 50 microvolt and the frequency is 7 to 14 Hertz. And if there is any disruption of the conditions producing alpha wave is there will be blockade of the alpha wave known as the alpha block. During REM sleep, if you record the EEG, it will show alpha block. Can you tell me why? It is very easy. Because during the REM sleep, the subject dreams. And in the dream, the subject chases the object. Subject chases the incidents which is occurring in his or her dream. And as a result of which there is rapid eyeball movement. And this rapid eyeball movement stimulus is going to disturb the normal alpha rhythm, leading to production of alpha block rhythm. So is this clear? So what will be the EEG picture of REM sleep? The EEG picture of REM sleep will be that of alpha block, no doubt about it. Though the eyes are closed, but the mind is not wandering. Mind is following some object in his or her dream, and as a result of that attention during dream, the EEG takes the shape of alpha block. Is this clear? Okay. Now that is about the EEG changes in the sleep, different stages of sleep, both REM sleep and the NREM sleep. Now we will go for mechanism of production of sleep. How the sleep is produced? It is an intriguing question. Why a person becomes asleep? Why the sleep occurs? Why the wakefulness follows sleep? These are the intriguing questions on which the scientists are working, neurologists are working, neurophysiologists are working for a long period. It has been seen for the initiation of NREM sleep, mind that, for the initiation of NREM sleep, the inhibition of the reticular activating system correlate the two things. As I told you earlier, this is a trilogy of neurology where rash, EEG and sleep are playing simultaneous roles. So if you consider that trilogy, if there is inhibition of the rash reticular activating system, so there will be overall suppression of the cortex, the consciousness will be diminished, the awareness will be diminished, cortex will be suppressed as a whole, as I told you. So inhibition of the rash is a precondition for the development of NREM sleep, which is the initial stage of the sleep, remember. Followed by the fact that in the brainstem at the pontomedullary junction there is a nucleus known as raphe magnus nucleus. At the pontomedullary junction there is a nucleus known as the raphe magnus nucleus over here, and from the raphe magnus nucleus fibers which discharge serotonin as a neurotransmitter, and that serotonin is one of the important reasons for the development of NREM sleep. So NREM sleep is having two important causative factors. One is the inhibition of rash or reticular activating system, another increased discharge of the serotonergic neurons from the raphe magnus nucleus. On the contrary, the REM sleep occurs as a result of another nucleus which is situated in the mid pons known as locus coeruleus, which is located in the mid pons, locus coeruleus, and that locus coeruleus discharges noradrenaline as a neurotransmitter via some fibers, which causes the switching over of NREM sleep to REM sleep. So what is the cause of REM sleep? Activation of the locus coeruleus nucleus, which causes discharge of the neurons having noradrenaline as neurotransmitter and thereby initiating the REM sleep. These are the two theories which have been propounded regarding the mechanism of onset of NREM sleep and the REM sleep. And when the activity of this REM sleep noradrenergic locus coeruleus pathway is inhibited, then the person awakes. So after the completion of all the cycles, of course, in the morning, the early morning, so after the completion of all the cycles, but in each cycle, the switching over from the NREM sleep to REM sleep is an automatic one. And the background of this automaticity, which have been explained chemically right now, is to be remembered. That is very, very important. That is locus coeruleus for the REM sleep and the raphe magnus nucleus as well as the rash for the NREM sleep. So that's about the mechanism of production of sleep. Now we will go to the applied aspects, the last portion, applied aspects of the sleep. Now you know quite well the commonest applied aspect of the sleep is insomnia. Commonest applied aspect throughout the world is insomnia, which may be irregularity of the sleep, which may be lack of initiation of sleep, which may be sustenance of sleep, whatever it may be, there must be some derangement in the mechanism of production of NREM and the REM sleep, as I have already mentioned, that will lead to insomnia, that means lack of sleep. And this lack may be initiation lack, the sleep is not getting initiated, or there is problem in the sustenance of sleep, early breakage of sleep in the midnight, so on and so forth. So insomnia covers a broad ambit of the derangement of sleep mechanism. Broad ambit of the derangement of sleep mechanism, right? Now, other things which are the features or the abnormalities of the sleep are sleepwalking. The person walks during sleep. The condition is known as somnambulism. The condition is known as somnambulism. Somnambulism. Somnambulism or sleepwalking. Sleepwalking. Or there may be sleep talking. The person may talk during sleep, which is known as the sleep talking. There may be grinding of teeth during sleep, known as bruxism. Bruxism, B-R-U-X-I-S-M. Bruxism. Grinding of teeth during sleep, which is known as bruxism. Bruxism. So these are the other abnormalities of sleep apart from insomnia. So insomnia, then the somnambulism, then the sleep talking, then grinding of teeth or bruxism, or there may be profound hypotonia of the muscle, so much so that even after awakening in the morning, the person feels extremely weak so far as the muscular activities are concerned. This may be another abnormality of the sleep so far as the different stages are concerned. So these are the applied aspects of sleep. Now to end with this fact that this PSG, which is written over here, PSG, what is that? PSG is a mechanism, is an instrument or is a method by which the sleep can be recorded, known as polysomnogram, and the process is known as the polysomnography. So if you want to record the sleep of a subject, you shall have to use this particular instrument known as polysomnograph or the polysomnogram is the result of the polysomnography. Well, what are the features which are seen? EEG, EMG, electromyograph, EOG, electrooculogram. So, by using a single instrument, polysomnograph, we can record three important electrophysiological events. Who are they? They are electroencephalogram, as I told you, the different stages of sleep. Then electromyogram, that is the electrical activity of the skeletal muscles, which will indicate hypotonia, as I told you. Or electrooculogram or EOG, that means which will record the movement of the external muscles of the eyeball, because during rapid eye movement, REM sleep, you shall have to record what are the magnitude of the movement of the extraocular muscles, that is EOG. So by using polysomnogram, we can assess the amount and the type of sleep, if there is the abnormality of the sleep, and the treatment will be given accordingly. So that's all for today.